Alright, so very good afternoon to everyone. A very good afternoon to all of you, my dear students. A very good afternoon to all of you. So, guys, my name is Dr. Shankar Tripathi, and I am your physics educator. So, in this session, we will be solving a few questions that we expect to come in your NEET examination, right? Moreover, so see these questions what I bring to you. Okay, so each of the question is a kind of curated question, and basically it helps you enhance your ability to apply the concept rightly or in the right way of a physics problem. Okay, so here we go with the first question. So all the live students, I'm expecting you to solve these questions and answer me in the chat. Yeah. So here we go with the first question. See, I have made some questions for you guys so that we can solve a few questions here, and basically it is going to help you understand the concepts. Okay, now please go for it. I'm very sure we can do. So the live students can respond to me on this. Please try to respond. Please try doing it. Let's try solving this question. So see, all these questions will help you enhance. So see, in physics, question solving is very important. So I'm waiting for the live students to answer. So live student, you may try answering me, beta. So now it says three like parallel forces, 30 kilonewton, 20 kilonewton, and 10 kilonewton are acting at points A, B, and C respectively on a straight line as shown in the figure. Okay, very well. The distances are AB is 2 meter, BC is 3 meter. Okay, very well. Determine the resultant force and its point of action from A. Okay. So what is going to be Yuvasri? Welcome to the session, my dear. So your answer is wrong. You are saying option 3. No, my dear, it is not the right answer. Okay, so see how we can be doing it. How we can be doing it. So see. So here, what will be first of all the resultant, my dear? What will be the resultant force? So the resultant force would be obviously 60 kilonewton, isn't it? The resultant force would be obviously 60 kilonewton because we see that there are three forces acting in the upward direction. One is 30, 20 and 10. So this is 60 kilonewton. This is 60 kilonewton upward force. This is your resultant. This is the resultant force. Okay. So resultant is 60 kilonewton. Resultant is 60 kilonewton in the upward direction. Okay. Now what is the Varignon's theorem? Okay. So what does Varignon theorem say? So if you take the moment about any point, okay, of the forces acting in a body, the resultant will give the same moment about that point. Okay, so I don't know that where this resultant is acting on the body, so let's assume that the resultant is acting at somewhere here. We don't know that where exactly this resultant is happening, but let us assume that this resultant is acting on somewhere at this point, that is at 60 kilonewton. Okay, so this is 60 kilonewton. Let me suppose this is x. Okay, now if you take the moment of this resultant about any point, if you take the resultant of this moment about any point, so it would be, so let me take about a. Okay, so if I take the moment about a, it will be 60 into x of the resultant, and this must be equal to the moment caused by each of the force about that point. Okay, so this 30 kilonewton will not give any moment. This 30 kilonewton will not give any moment about A. Do you agree to it? This 30 kilonewton is not going to give you any moment about the A, right? Why so? Because there is no perpendicular distance. But this 20 kilonewton has a perpendicular distance with respect to point A. So this will be 20 into 2, and this is going to be 10 into 5. This is going to be 20 into 2, and this is 10 into 5. So this will become 140, and this is 60 of x. So 140, and this is 60 of x, isn't it? Oh, sorry, this is 10 into 5, so it is 50, not, so it is 50 plus 20, that is 90. So 60x is equal to 90. So x will be 9 by 6. 9 by 6 is 1.5 meter. So what should be the answer? So the resultant is 60 kilonewton. It is acting at a distance of 1.5 meter from the end A. Okay. Okay, so it is written in the question is point of action from end A. That means the location of this force from the point A. I hope it is fine to you, Bida. Right? Any issue? Any issue? Okay, let's try a simple question. Okay, this is a very simple question. Let's try this one. Come. Please do it. Please try doing it. Uh, the cakewalk and you are free. Please try answering, beta. See, I am very sure that you can do. No problem at all. Please try doing it. Please try doing it, my dear. See, I'm very sure we can do. Very simple. Please give me any answer to this question, my dear. The live students. Please try answering it. Anyone? See, today I'll be giving you multiple physics question or multiple concepts. This is not like I'm going to give you the questions from one concept. I'll be giving you multiple concept questions. Okay. Any live students? Any answer, my dear? So the live students, welcome to the session. My name is Dr. Shankar Sir. I am PhD from Indian Institute of Technology, Roorkee in mechanical engineering, and I am your humble physics educator. Okay, so now I'll do the question. So very simple question. Now the next question is going to be very tricky. Okay, be careful. So what we are trying to do, I'll infuse the multiple concepts. I'll give you questions from different concepts. Okay. Now it says a body of 100 kilonewton is placed on a rough horizontal plane. So we are having a horizontal plane which is rough. Okay, so we are having this horizontal plane. Determine the coefficient of friction if a horizontal force of 30 kilonewton. So the weight of the body is 100 Newton. Weight of the body is 100 Newton is placed on a rough horizontal plane. Determine the coefficient of friction if a horizontal force of, so this is 100 kilonewton actually. 100 kilonewton. It's very simple, no? Determine the coefficient of friction if a horizontal force of 30 kilonewton. Horizontal force of 30 kilonewton just causes the body to slide over the horizontal plane. Okay. So see, this is a 30 kilonewton force which is causing. So what we do? So we have some friction force. So there will be some friction and there will be some normal reaction. So simple. This is very simple question. See, simply by using the static equilibrium condition, this is Fn, F is friction force is going to be 30 and the normal reaction is going to be 100. Now what is the coefficient of friction? Coefficient of friction is obviously F upon N. Coefficient of friction is what? It is F upon N. So what is F? That is 30 divided by 100. So it is going to be equal to 0.3. So that is your A option. Understood? Understood? I hope it is fine to everyone. Okay, let's try one more question. So this is a very good question. Okay, this is not from NEET, not from IIT. This is actually, a PG level examination question. Okay, but see, when some questions are helping you to understand the concepts well. Are you getting my point? Okay, let's try this one. Come. See, live students, you need to answer whatever problem, and if any concept also you want to understand that regarding the question that so we didn't understand it, you can always ask me. But you must try solving it. See, unless you try, you won't be able to get something. Okay. The live students, please try answering me, beta. See, unless you try, it is not going to work for you. See, physics is not about, remembering the formulas. Are you getting my point? Physics is not about it. If you want to understand the physics, if you want to see, ultimately in the examination, questions are coming. So see, whenever you see a question, you try, if you are trying to, use the concept in it. So how the concept can be used in any question, that is something of utmost importance. And that is the way only moving forward in the physics. Okay, please try it, Bida. Let's see if we can do. All of you. Please do. The live students, please try answering it, beta. See, read the question carefully. See, sometimes so much. So this is the third question of this session. So much data sometimes are given in the question just to in order to confuse you. Okay, sometimes just to confuse you, you are given with all these informations. Are you getting my point? So don't let yourself be confused and please try answering it. See, there is nothing in this question that you can't do. This is a question of what? The properties of fluid. Okay. Please try answering it. Please try answering it, my dear. Any students who is attempting the question or shall I do it? Anyone who is attempting or shall I start doing it? Okay, okay, I'm waiting. Any answer from you guys? Any answer? The live students, please try answering it, beta. Very, very good question. See, from this question, you are going to understand a lot of things of fluid. And see, recently so on this channel, let me tell you, on this channel we have completed unison measurement. That is the first chapter actually. The second is motion in a straight line is completed, vector is completed, motion in a plane is completed. The properties of solid is about to be completed. Only one session is left. Something of a stress strain curve and shear stresses and bulk modulus thing. That is volumetric stresses. I have to tell you. So maybe one more session will be required for that. And afterwards, I'll be starting with the fluid. Okay, because many students have a lot of problems in the fluid section of physics, so I'll be coming up with that. Okay, so what I tried to doing it, so physics of 11 part 1, I did 3 chapters. Now I am doing 3 chapters of physics class 11 part 2. Please try doing it. How can we do it? So I'll do it now. So it says air flows through a venturi, air flows through a venturi and into atmosphere Air density is rho, atmospheric pressure is PA, throat diameter is dt, exit diameter is d, exit velocity is u. The throat is connected to a cylinder containing a frictionless piston attached to a spring. The spring constant is K. The bottom surface of the piston is exposed to atmosphere. Due to the flow, the piston moves by the distance x, assuming incompressible flow. So x is. Now see how they complicate the information in this question. So see, you must know that venturimeter works on the principle of Bernoulli equation, and also it is a flow measurement device. I hope all of the aspirants are well aware of this, right? Now see, in this what we have to do, we have to find this x, okay? And the spring stiffness is given in the question. Now when is stiffness of the spring, uh, ultra, good morning, good afternoon, sorry. So we are trying this question. Are you attempting the question, my dear? Are you attempting it? Hmm? Shall I wait for you to attempt? Do we have any answer to this question? Okay, so I was saying, see what happens now in this question, please understand this. So see, they are asking you the displacement, that is the x of the spring, and we are having some stiffness given to us. Now see, ultimately, what is this x? So stiffness is what? Stiffness, we understand that it is force upon displacement. So x is equal to force upon x, force upon k, F upon k, right? Now, when this k is F upon x, so what does that mean? Okay, so if you have, so x is F upon k, so if you can from somewhere, if you can get this k value, oh sorry, the F value, the force if you can get on the spring, you will be able to get the displacement. And since it has something to do with the Bernoulli, so we can do, see, this is how you can approach a question. So see, this is a question of Venturi. So I may try to find the force here by finding the pressure. So let me say that this is section, let me call it section T. Okay, and this is all section 1 only, and this is your section 2 just outside. This is your section 2 or point 2. Right. So see, from Bernoulli equation, I can try to figure out, or I can try to find the pressure at point 1. I can try to find the pressure at point 1. Okay. Okay. And once I have the pressure at point 1, I can have it multiplied with the area. I can have it multiplied with the area to get the force. And once the force is found, we can find the x. Right? Agreed? Do you agree to it or not? Yeah. If we can find the pressure at section 1 and we multiply it with area. So what is the force? So force is pressure into some area. So when you are having the pressure on some surface or some area, you can obviously then multiply that pressure with the area to calculate the force. Okay, and once force is calculated, you can easily calculate this x. So see how we can do. So let me apply the Bernoulli equation between point 1 and 2. So it will be P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g, P2 by rho g plus V2 square by 2g, V2 square by 2g. So now it will become P1 by rho g. So this is P1 by rho. So g we can cancel out. Now what is this V1 square? Let me write it like this only. So I'll just leave a space here. Then what is P2? So I can consider this is atmospheric because it is at the exit. So atmospheric I can consider 0 only. Okay. So why you are considering 0? So see, when you are considering the pressure atmospheric to be 0, so right away you are getting the gauge pressure. Gauge pressure means that the excess pressure. So that excess pressure only will be exerting the force on the spring. No, Sangeet. Sangeet, you were saying something, but it seems that you have retracted your message. Okay. So now this is P1 by rho, and this is, for this I'll leave some space. This will become 0, and this is become u square by 2. Okay. Now see, between V1 and V2, uh, Sangeet also in today's session, I haven't prepared the question of the magnetic material, my dear. Right. So in this session, I have come up with, I see these questions I have to now figure out. See, I don't want to give you some any question, right? So let me work on it. In the next session, I'll come up with a magnetic material question also. Sounds good? Yeah. So I have, like figured out some question from different examination happened across India of the physics, and these questions belongs from the Newtonian mechanics, right? Some from the fluid, some from the mechanics of solid part. Okay. Today I haven't prepared the 12th question, 12th physics question, right? In the next session, maybe I'll come up with those as you have come in this session and asked me that thing. So, yeah. See, I don't want to give you some random question. Let me work on it and basically I'll figure out. So, see, like this question. This is a question of fluid. Okay, it is, see, I have searched many examination and I have come out with some questions, okay, that may, trigger your concept in that. So let allow me some time. Okay, in the next session, I'll give you the questions of these also. Sounds good, my dear? Yeah? Because today I don't want to waste your time by giving some random questions. Are you getting my point? So from these questions, not only you will solve it, it will help you understand the concept. So have you tried this question, Rudra? And thanks for coming in the session. My name is Dr. Shankar Sir. Welcome to the session. Very good afternoon. Have you tried this question? Do you want to try this question? This is a question belongs from the properties of fluids. Would you like to try this question? First, hmm? Or shall I proceed solving the question? Okay, so I'll proceed with solving the question. So see what we are trying to do, we are trying to figure out the pressure at this section 1 so that we can multiply this pressure with the area to get the force and ultimately get the compression of the spring. Now see, can I relate the velocity at 1 and velocity at 2? Yes, sir, most certainly through the continuity equation we can do. So can we write A1V1 is equal to A2V2? Can we write like that? Now A1 is what? It is pi by 4. So the diameter here is given as dt square V1, and A2 is pi by 4 d square u. Pi by 4 d square u. So V1 is d square upon dt square of u, isn't it? D square upon dt square of u. Now if I place this in this equation, I'll be getting V1 will become d to the power 2 upon dt to the power 2. So when we are squaring it, it will become like this, power 4 u square, and 2 is already there, right? Now from this, can we get the p value, p1 value? Yes, sir, seems like that. So P1 will be, so it will be u square by 2. It will be what? It will be u square by 2, and it will become 1 minus d to the power 4 upon dt to the power 4. 1 minus d to the power 4 upon dt to the power 4. Right? Okay. 1 minus d to the power 4 upon dt to the power 4. Is it? Yes or no? Can we write like that? Okay. Yes, sir. Absolutely, we can write like that. So now see, this is your pressure, and see, there is one rho also. So it will become rho u square by 2 1 minus d to the power 4 upon dt to the power 4. Now what will be the force then? So force will be this pressure. Force will be this pressure multiplied with this pressure multiplied with the area. So what is the area here? So the area is pi by 4 ds square. The area is pi by 4 ds square. So this is going to be your force, right? Okay, so what will be the x? So x will be, so this is going to be divided by k. So rho u square by 2k. And remember, see, this is a compressive. So it is compressing the spring. Na? So for compression, you can, add a minus here, right? So normally the sign convention we use is negative for the compressive load and positive for the tensile load. Okay, compressive for the negative and positive for the tensile. Okay, so the same thing we are doing here. So it will become, so if I multiply this minus inside, it will become d to the power 4 upon dt to the power 4 minus 1, and this is pi by 4 ds square. This is pi by 4 ds square. Understood? Okay, so see, if you multiply this pi by 4 there or 4 there, you will see that your D option is exactly matching. Okay, our solution, isn't it? Okay, it will become rho u square, it will become rho u square by 8k d to the power 4 minus upon dt to the power 4 minus 1 pi ds square. Understood, beta? Please answer me. Yeah, please give me a yes or no. Agreed? Please answer me. Yeah? Okay. Now let's try one more question. Okay, please try this. Let's try this one. I'm very sure we can do. Relatively simple question. Okay, because I want you to at least answer a few. A good question again. Not from the NEET examination, not from the IIT examination. Please try it. Please try it. Please try it, guys. So, Aman, you have answered something. No, your answer is not correct. See, this is the mistake sometimes we do. How you did it? You are saying 4p is your answer. No, this is not the answer. Any other students who want to try it? Okay, I'll do. See, it's simple question. So it says find the magnitude. So this is something of the vector also, right? It says find the magnitude of the unknown force. And also, Aman, if you are so please do this question also. Na, lately, this is a wonderful question. Okay, of the fluid properties of fluid. Okay, let me come to this question now. So find the magnitude of the unknown force F if the resultant of the four forces, that is Fp, 3p, and 5p, acting at a point O is 2 root 2p as shown in the figure. The four concurrent forces 3p and 5p act in the vertical direction. P and F are in the horizontal direction acting at point O. Now please observe. So see how we got to do this. So now this is the resultant of all these four forces and F is unknown. So we want to have the F in terms of P. So can I do like this? So this 5P and 3P. 5p in the upward direction, 3p in the downward direction. So this will become 5p minus 3p. So this will become 2p. And this is going to become f minus p. This is going to become f minus p. Right? And this is going to be 2 root 2 of p. 2 root 2 of p. Right? 2 root 2 of p. And this is given as 45 degree. This is given as 45 degree. So this is the resultant, right? This is the resultant. So see, it has, I hope that we know or we remember the law of parallelogram of forces, isn't it? The law of parallelogram of forces. Okay. So now see from this what we can do. So from this we can find the resultant of it, right? Can we find the resultant? Huh? Can we find the resultant of it? What is going to be the resultant? So now I see that this F minus P, and this 2P. So these are the two forces, or I can do by the, so see, so the resultant, the resultant of 2P and F minus P, okay? 2p and f minus p. So this is the resultant and this must be root over, or r square must be 2p square plus f minus p square, isn't it? So two forces acting perpendicular to each other. Two forces acting perpendicular to each other, and the resultant shall be like this. The resultant shall be like this, isn't it? So now from here it will become r square. So the resultant is given. So it will become 8p square, right? So I'll just have put the value of the resultant. So it is 8p square, and this is going to be 4p square, okay, plus f minus p whole of a square, right? So this will become f minus p whole of a square, and this is going to become 4p square. So from here it will become f minus p, that is 2p, right? 2p. So from here can we write that f is equal to 3p, isn't it? F is equal to 3p, isn't it? Isn't it? Please answer me. Yeah. So what shall be the answer? The answer shall be A option. Is it fine, beta? Please answer me. Please give me yes or no. Please give me a yes or no. Please give me something. Alright, let's try one more question. Okay, again a multi-concept question. Please try it. Let's see what we are getting. Wonderful, Aman. Now please try this one. Again a very nice question. Please try it, my dear. Oh, so figure is also there. I'll just make one figure, no worries. A simple figure is there in the question. Yeah, let's try. This is the figure in the question. Yeah, this is the figure only. Actually, no need of figure in this question. This is your balloon. This is something like this. Please try. Again, it will require you to apply some concepts. Actually, in this question, the figure was not at all needed. Please try. No, it is not a question of JEE Advanced, but it is sort of multi-concept question. So I have searched for many good questions of physics of multiple topics, and I found some very good questions. They are asking good examinations. Some are from Olympiad, some are from some other prestigious examination like GATE examination, UPSC examination, NET examinations. So all of these questions, see, question in physics, I'll tell you one thing. Physics is all about creating the approach, right? You cannot understand the physics unless you try applying the concept that you have in the questions. Okay. So sometimes, see, like in this question, you may be required to use some sort of, heavy calculation might be there, but that is not the point, guys. That is not the point. That this question, see, we cannot comment or we cannot, some people say that okay, this question will definitely come in the examination. I don't say things like this. This is not practical. Very good evening, AK. How are you doing? With a long time. So from these questions, what is my aim? What is my purpose? So my purpose is that you, come out with some concepts like how to use the concepts in the physics problem, how to approach one problem, right? Please try doing it. Hmm. It seems to be, yeah, actually, yeah, correct only. Wonderful, Vitamin. Very nice. Really appreciate. Okay, so now I'll try. You are aspiring for NEET examination, AK, right? So in NEET examination, see, not much mathematics you require. A little of differentiation and integration. That will be suffice. Okay. So now see, a spherical balloon with diameter 10 meters shown in the figure below is used for advertisements. The balloon is filled with helium. Okay, so this is balloon is having some helium inside. The balloon is filled with helium at ambient condition, that is temperature and pressure is given, assuming no disturbance due to wind. Assuming no disturbance due to wind, the maximum allowable weight of balloon material and rope required to avoid the fall of the balloon. Required to avoid the fall of the balloon. Okay, now please understand this. So, see, they are saying the maximum allowable weight of the balloon material and the rope. So see, what will be the things here? What will be the forces working here? Okay. So there will be some weight of the helium that must be acting in the downward direction. Weight always acts in the downward direction. Then there will be some weight of the material and weight of the rope. Okay. Weight of the rope that must be again acting downwards, and this will be, yeah, it is right, it seems, Aman, right only, beta, wonderful. So now weight of the helium will be acting in the downward direction, weight of the material and rope is acting in the downward direction, and since this balloon must have displaced some fluid. What fluid? Obviously air. So this balloon must have displaced the air, so there will be some buoyancy force, isn't it? So what is the buoyancy force? So whenever an object is immersed in a liquid, it is acted upon by a force which tries to lift it up. Archimedes principle, isn't it? Okay. So now this is going to be balanced with the force of buoyancy. Do you agree to it first of all? So again, this is a simple force balance. Some forces are acting downward, some forces acting upward. So this is simply the force balance. Do you agree? Yes or no? Please answer me. Do you agree to it or not? Please answer me. Yes, sir. Now, to solve this question, what will be required? So, the weight of the material plus rho. Okay. See, in physics, they can do anything to confuse you, right? So, buoyancy force minus weight of the helium. Okay. So, if we are able to find the weight of the helium and if we are able to find the buoyancy force, that is the weight of the air that is displaced, we'll be able to solve the question, right? We will be able to solve the question. And the live students, see, those who are new to this channel, thank you very much for joining in. My name is Dr. Shankar Sir. Please subscribe the channel also. This will be of great help. Okay. Now the material of the weight and the weight of the material in the rope is going to be this. So let's try to find this thing. Okay. Let us try to find this thing. So see, what is going to be the weight of the helium, guys? So see, we are given with some data. What is the data given in the question? What is the data here given in the question? So we are given with some data. What is the data given? So we are given with the data that the R of helium is given. So see, helium is an ideal gas. So we can apply this equation. So for helium, if I apply, so let me write it like this. So PV is equal to MRT. That is we know. That is what we know, right? That is what we know as the what? As the ideal gas equation. And here I'll be using the mass of the helium, the R of the helium, and the T of the helium. Do we agree? Yes or no? Please answer me. Right. So this equation, are we aware of this equation? Yes or no? Please answer me. Are we very well aware of this question or not? Yes, sir. Definitely we are aware of this question. So we can find the mass directly or we can find the density. So if we want to find the density, because see, I'll have to, reduce the calculation. So we always try to reduce the calculation. So the density is going to be pH upon RH into TH. So what is the pressure? What is the pressure? So it will be 100 kilopascal. Please take care of the units. So this is the density of the helium we are talking upon R of the helium, that is 2.08, and what is the temperature? Temperature is 15 degree. Now do remember this thing that we always use. So the absolute pressure, we always use the absolute pressure, and we always use the absolute temperature whenever we are applying the ideal gas equation, right? Do we or don't we? Yes or no? Whenever we are applying the ideal gas equation, we are always using the absolute pressure and absolute temperature. So what is going to be the density of the helium? So when we make some calculation from here, we will be getting 0.167 kg per meter cube. So we are now having the density of the helium. Okay. So what will be the weight of the helium then? So weight of the helium, it is going to be density of helium, right, into G into volume. Okay, this is the weight, no? Weight is what? Weight is the mass density multiplied by G multiplied by the volume of the helium. So this is going to be the weight of the helium, that is 0.167. What is the G? This is, we can consider as 9.81. Okay, we can consider it as 9.81. And what is the volume? So it is said that the diameter is 10 meters. So the diameter being 10 meters, so this is going to be 4 by 3 or pi by 6 d cube. So what is the d? D is 10 meters. So let's take care of the unit. Okay, so every unit we are putting rightly. Okay, so it will be pi by 6 10 cube, isn't it? It will be pi by 6 of 10 cube, or you can use 4 by 3 pi r cube, whatever you want. Okay, 4 by 3 pi r cube. So from here you will get the weight of the helium. Now what about the air? Okay, so we are having the R of air also. So now the density of air we can also find, because see, what is the force of buoyancy? It is the weight of the liquid displaced, isn't it? So what is the fluid? What is the fluid that is being displaced in this problem? So the fluid being displaced is the air. So the force of buoyancy will equal to the weight of the air that is displaced by this volume of the balloon. I hope you are understanding the concept, right? If there is any problem, please do ask me at any point of time. So density of air will be pressure. Now R of air and temperature. So what will be the density of air? So pressure is again 100 kilopascal. Okay. So what is the weight of the, what is the density of the fluid, that is air, which is being displaced here? So it is 100. What is R? So R is 0.289. So for the R, that is characteristic gas constant of the air, you must remember also. And the temperature is 15 degree, that is again 288. That is again 288. So from here you can get the density of air. So it will be 1.2 kg per meter cube. 1.2 kg per meter cube. So the density of air we have got here. The density of air we have got here. So what will be the force of buoyancy? It is equal to the weight of the fluid displaced. So it will be rho of air G. And what is the fluid? What is the volume of fluid being displaced? So it is obviously equal to the volume of the, balloon. So what will be getting? So density of air, that is 1.2 into 9.81 into sorry. So this is going to be 9.81 into pi by 6 d cube, that is pi by 6 into 10 cube, right? So now you have the weight of the helium, you have now the force of buoyancy, so you can have them subtracted. And when you are going to have them subtracted, you are going to get the weight of the material and weight of the rope. Okay, weight of the material and weight of the rope, and when you do it, you are going to get 5303 Newton. What we are getting, beta? We are getting 5303 Newton. Understood, beta? Okay. So this calculation are very hard calculation. See, as I said, my purpose here is not to, make you solve the question. You don't come to the right answer, that is okay. But if you are trying to put the concept rightly of the physics, that we are having some value addition. Are you getting my point? Did you understand this question? Those who are watching me live here, I want to ask you this. Do you understand this question, beta? Please answer me. What do you say? Do you understand this question or not? So Aman, you have solved it correctly. Wonderful. Shall we try one more? Yeah. Okay, let us solve one more question. So you have to give answer in mm. Okay, please go for it. You have to answer this in mm. Please try answering. Please try answering. Please try doing it. Wonderful, Aman. I'm expecting right answer from you for this question also. You need to answer in, you need to give the answer in the unit of mm. Good. Please do. Ha, Aman. See, again, please try to understand. See, these questions will help you create an aura in your mind that how we can apply the concepts of physics. The last question you did it correctly only. 79.5. It is correct only. It's very near to the correct exact answer. Wonderful, Bida. You are putting the right concepts. So now let me do it. So it says a cube of side, and the remaining students also. You please try to solve this question. This will help you understand that how you will be able to. So all this concept you already know. See, in the last question, we already know this PVMRT. We know the concept of UNC, right? We know the concept of so I place it here. Yeah. So it says a cube of side 100 is placed at the bottom of an empty container on one of its faces. See, in physics, what they can do, your answer is correct only. So see, what they do normally, so in the physics, there is a lot of scope to twist the language of the question. One easy concept question they can make in a way that the language is so much complex that students, feared before answering the question. Okay, so we have a cube of side 100 It is placed at the bottom of an empty container on one of its faces. The density of the material of the cube. So density of the cube is given. The density of the liquid is given. So liquid of density 1000 kg per meter cube is now being poured into the container. The minimum height to which the liquid needs to be poured into the container for the cube to just lift up. So what is that fluid they must be pouring? So obviously, sir, it is water because density is given is 1000 kg per meter cube. Now they are saying that they are pouring the water. They are pouring the water, and when they are pouring the water, till what height? Till what height this water shall be poured, so that it is begins to lift up. Okay. Now let me assume. So there's nothing to assume. This is a cube. So when it is a cube, my dear, when it is a cube, my dear, so it is going to have the side of 100 mm. It is going to have the side of 100 mm. Okay, so this is 100 mm, and we want to find this x here. Okay, we want to find this x here. Now, when it will be, it is right only. It is right. Very good. So when you are going to, so when it is going to lift it up, so it is going to lift up when the force of buoyancy becomes greater than or equal to the weight. See, whenever a body is immersed in a liquid, it is acted upon by a force which tries to lift it up. And the weight of the body is always acting in the downward direction, right? So force of buoyancy is acting in the upward direction, the weight of this is acting in the downward direction, right? So what is going to be the force of buoyancy? So force of buoyancy is simply, see, this is just the twisting of the language. They say a cube is placed, water is poured, right? Sometimes they say till what amount the water shall be filled in the boat. There is a hole in a boat, the water is filling in. Till what amount the water must be filled, like that they can complicate the language of the question to any extent in physics. Okay. Now force of buoyancy, we know it is the weight of the liquid displaced by the immersed portion, right? So see how it is. So what will be the force of buoyancy? It is the density of the liquid. It is the density of the liquid into G into volume. So what will be the volume? Area into the X, right? The force of buoyancy is the weight of the liquid displaced, right? So this is going to be density of liquid into G into volume of the immersed portion. So what is the volume of the immersed portion? It is going to be area into X, and this is equal to the weight. So weight of the cube material, weight of the cube, okay, into G into volume, that is area into the height, that is 100 mm, isn't it? Do you agree? Right. Volume of a cube will become L cube only. Volume of the cube become L cube only. Right? Yes or no? Okay. Okay. So now what is the density of liquid, sir? It is 1000. Area G will be cancelled out. It is X. This is going to be the density of the cube. This is 800, and this is going to be into 100. So what we are getting from here? We are getting X is equal to 80 mm. So you answered 79.5, 79 mm. So it is actually 80 mm. Understood, beta? It is 80 mm. So at 80 mm, what will happen? If the x becomes 80 mm, the cube will just start to lift up. Understood, beta? The cube will just start to lift up. Right? Please answer me yes or no. Okay, let me give you one more question. Did you understand the concept, beta? How come you are getting 79.5? The other live students also please try answering the question, beta. Okay, let us have one more question. Okay, please try this one. I'm very sure we can do it. Please go for it. Please try answering. Please try to solve the question, guys. Please try. Wonderful, wonderful. Please try this question. Hmm? The upper part of question you cannot see. I'll just paste it like this. Now can you see it? See, this is the figure associated. Right, I think you can see it now. Yeah. So the new student to the channel, welcome to the channel, my dear. My name is Dr. Shankar Sir, and if you haven't subscribed the channel yet, please do. Again, an interesting question. Please do. Please do. So, Aman, you have answered something. So this is relatively easy question, na? Relatively easier question. Your answer is yeah, correct only. Wonderful. See how we can do it. So it says the large vessel shown in the figure contains oil and water. Okay, very well. A body is submerged at the interface of oil and water such that 40% of its volume is in oil and while rest is in water. The density of the body is, so we have to find the density of the body. So see, in this case, so what will be the weight of the body? So see, whenever a liquid is submerged in a, whenever a body is submerged in a fluid, there is a buoyancy force and the weight is balanced by the force of the buoyancy. Now here, this is submerged in two liquids. So the force of buoyancy will be, what will be the net force of the buoyancy? It will be equal to the force of buoyancy that the oil will offer, that is the first fluid will offer, and the force of buoyancy the second fluid will offer. No, no, it is very near. It is very new. See, I am not, see, today I am not at all interested in the calculation. I am interested in the concepts. That are you able to apply the concept rightly or not? That is our motive in the session. Are you getting my point? I am not interested in the calculation. I am interested that whether you are able to apply the concept rightly or not in the physics. Okay? These questions are not of the NEET examination. Right? Okay? So these are very good questions. Sometimes, see, we have to do some questions to understand the concepts even. Okay? Now, see what is going to happen. So it is going to be the weight of the body. So weight is the density of the material into G into volume. Now force of buoyancy in 1. So I'll write it as oil and this is water. Now what will be the force of buoyancy in oil? So it is going to be the weight of the oil displaced. So see, it says a body is submerged at the interface of oil and water such that 40% of its volume is in oil. So can I write density of oil into G into, so what part of volume is immersed in the oil? So 45% is immersed in the oil. How much? 45%. So when 45% is immersed in the oil, it is like this 0.45 of V. Since the 45% of the volume is immersed, then it will be density of water into G. So if 45% is taken by the oil, the remaining must be taken by the water. Remaining must be taken by the water. It is correct only. No worries. Now from here, the G, G, V, G, G, V, all these are striked out. So density of the material is going to be 0.45 of the density of oil plus 0.55 of the density of water. So what is the density of oil, my dear? The density of oil given in the question is, so specific gravity is zero point 0.7. So it is going to be 0.545 of 700. And this is for water, that is 0.55 of 1000. So this will become how much? This is going to become 865 when you calculate it. 865 kg per meter cube. So did you understand the question or not? Please answer me. Have you understood? Yes or no, beta? Please give me a yes or no. Yeah? Agreed? Any issue? Okay, so let's try some more questions. Just a moment. Okay, let's try this one. Okay, let's try it. I'm very sure we can try. Can you see the complete question? Please try to do. It is relatively a simple question. Please try to solve it. Any answer, my dear? Aman, any answer, beta? And what about the rest of you? Any answer to the question? Please answer. The live students, you can please try to answer the question, beta. Any answers? Any answers, my dear? So, shall I try answering the question? Please do, guys. Okay. Now, how can we do it? So it says if resultant of 1000 Newton and P1 as shown in the figure is P2. Okay, then P2 is. So we are supposed to find this P2. We are expected to find this P2. Okay, so how we can find this P2? Okay, so how we can find this P2? So see, now please understand this. So how we can do? So see, in this question, how we can try? So it is again a question that comes from the vector, the law of parallelogram. Okay, so if you apply the law of parallelogram of vector addition, you will be easily be able to solve this question. See how? Now, what is the law of parallelogram? So we understand that if two forces are there or two vectors are there, let's suppose this is F1, this is F2, okay, and the resultant of these two vectors is somewhere here, and this is alpha, and the force between them is theta. So we know that tan alpha, we know that the tan alpha is going to be equal to what it will be. It will be how much it will be. See, F1 on this is going to be F2 sine theta plus F2 cos theta. Right? This is the formula we have seen, we have derived, we are knowing from the law of parallelogram of vectors. Okay, and forces are the vectors, so you can very easily apply this formula here also. So tan alpha. So alpha is what in this question the resultant is at an angle of 30 degree. So tan 30, this is going to be, so F2 is what here? F2 is P1. And the theta is also given. The theta is the angle between these two vectors, that is 45. That is 45 divided by F1. So here in this case F1 is 1000, right? It is 1000, okay, plus P1, okay, this is P1, right? P1 cos theta, that is cos 45. So from here can we calculate the value of this P1? Yeah, can we calculate the value of this P1? Yes, sir, definitely we can find the value of this P1. So from here when we do the calculation, we'll be getting P1 as 1931.85 Newton. 1931.85 Newton. Are you getting my point? 1931.85 Newton. Okay. Okay. So 1931.85 Newton, that is what we are going to get as P1. But they are asking you the resultant, which is P2. So what is P2? So it is P2 square is equal to P1 square plus 1000 square plus 2 times P1 1000 and cos 45 cos theta, that is cos 45, isn't it? So P1 already we have got. So once we have the P1, so we can apply, we can put it into this formula, and definitely we can get the P2 also. So P2 is 2732 Newton. Okay, so this is how we can approach this question, right? Easy, no? Okay, now let's try one more. This is relatively simple question. Let's try this one. Okay, let's try this one. Let's try this one. I'm very sure we can do. Please go for it. Let's try this one. Please do it. Please do it. Please try doing it, guys. I'm very sure we can do. Please try solving it, beta. Quite a simple question. Please do. Please do. So very simple question. See, this is relatively easier question. Very easy question. So it says force in the cable AB shown in the force in the cable AB shown in the above figure is. So AB. So what is AB? So we need to find this. Let's name it something. Let's name it F. Okay. And this is given. Now if this is 30 degree, this is also 30 degree. Right? Just a minute. Just a minute. Okay. So now let me assume that this is F and this is, let's suppose, P. So now this angle is 30, this is 90 obviously, this is 90, and this is what? This is so this is 30, so this has to be 150. This has to be 150. So we need to find this F. So can we use the Lamy equation? Okay, or you can do by the vector also, but Lamy will help you solving the question relatively easier. So f upon sine 120, f upon sine 120 is equal to 100, that is the force, that is 100 divided by sine 150, divided by sine 150. So this will become f is equal to, this will become f is equal to, how much it is going to become? So this is going to become C. So we need to make the calculation. Just a moment, guys. So, so when we make the calculation to it, we are getting 100 root 3, right? So that is the A option. I hope it is fine to everyone, right? Okay, so let's try one more. Okay, please try. I'm very sure we can do. Please do. Please try answering it, guys. I'm quite sure we can do. See, relatively a simple question. The live students can respond to me on this. See, in the last session we have did the mechanics of solids. That is the properties of bulk solids. So I took a somewhere 5 hours 30 minutes session last day, right? And there we have seen all these concepts of thermal stresses and all. Right now you have to apply those concepts here. Please try to do it. I'm very sure we can do. Please try to do. Please do it. I'm very sure we can do if we try to do it. So see, what does this question say? So it says a steel cube with all faces free to deform. Okay, has Young's modulus, Poisson ratio, coefficient of thermal expansion. The pressure, that is the hydrostatic stress, developed within the cube when it is subjected to a uniform increase in temperature, that is delta T. So what is this going to be? So this is going to be zero only, na? How come? Because this is free to deform. So what we have learned and what I have explained you, so I have explained you this thing that whenever a body is free to deform, when some temperature change happen in a body and it is free to deform, it can have whatever deformation it wanted to have, then there is no reason for stress to come in that particular body. Okay, so this is going to become zero here, right? This is going to become zero. I hope that's fine to everyone, right? Let's try one more. Please try. Please try answering it. Sorry, let's try it. I'm very sure we can do. So what does it say? It says a metal bar of length 100 mm is inserted between two rigid supports and its temperature is increased by 10 degrees Celsius. If the coefficient of thermal expansion is this and the Young's modulus is this, the stress in the bar is. So alpha is given as 12 into 10 to the power minus 6 per degree Celsius. Young's modulus is given as 2 into 10 to the power 5 GPa. 2 into 10 to the power 5 GPa, and it is said that we are having 2 inside. So we are having a bar inserted inside two rigid supports, and the temperature is increased by 10 degrees. So now in this case, what is the thermal stress, guys? We have learned. So it is alpha delta T into E. Okay, so what is the alpha here? So alpha is 12 into 10 to the power minus 6. Okay, delta T is what? Delta T is 10 and Young's modulus is 2 into 10 to the power 5. So what we are getting? We are getting 24 megapascal, right, beta? 24 megapascal. So that is your C option. Okay. So guys, in this session we have done quite a many questions. Okay, we have done quite many questions. We have done some really good questions. So I'll be coming up with some more sessions on some more questions that will enhance your understanding on the physics, and the questions will trigger you your concepts, and it will enhance your physics question solving ability, right? So see, in physics this is very important that you learn the concept well. Okay, you firstly you have to learn the concept well, and also and also um, when you are learning the concept, it is also very important that you can apply that concept. You can apply that concept in the direction of solving of your question. Okay, so I'll keep it to this session. In this particular session, I'll be keep it to this point, and I hope you guys have enjoyed the session, you have understood the session. So please don't forget to subscribe the channel. Please do subscribe the channel. Please watch the videos, and please share to your friends as well. So with this, thank you very much. Have a good day. My name is Dr. Shankar Sir, and I'm going to see you in the next session.